The experiment is AC voltage controller using triac-diac combination. The aim of the experiment is to study the working of an AC voltage controller for controlling brightness of a lamp. The components used here are AC voltage controller module, and we require a power scope for observing the load voltage waveform, and also we will be measuring the output AC voltage by using a digital multimeter. The circuit diagram of AC voltage controller is as shown here. In this, this is a 1:1 transformer. This basically we have already a transformer isolated power supply which is available. So the module basically is this part of the circuit which is available as a AC voltage controller module. So in this AC voltage controller module, so we have a lamp as the load, and we have a triac which is basically used as a bidirectional controlled device, and this triac is triggered using a RC firing circuit, and the gate pulse is connected. There is a gate voltage which is a voltage across a capacitor is used as a gate voltage, and that voltage is connected via a diac. So this basically capacitor, resistor, and this diac basically forms a firing circuit which generates triggering pulse for the triac. So let us look at the connections. The power supply, one end of the power supply, these are the two ends of the power supplies. One end of the power supply goes to lamp, the other end of the lamp is connected to 22 kilo ohm resistor and MT2 of the thyristor, that is a triac. This 22 kilo ohm resistor is connected to 50 kilo ohm potentiometer, and other end of the pot is connected to capacitor, and the other end of the capacitor is connected to MT1. Now these two shorted ends are then connected to the power supply. So let us look into the connections in the circuit diagram, in the module. The power supply, so this is the power supply wire. Okay, so one end of the supply is connected to lamp, that is the red wire of the lamp. Other end of the lamp, which is a yellow wire, it comes back and connected to 22 kilo ohm resistor, and same point is also connected to MT2 of the triac. And this 22 kilo ohm resistor is then connected to potentiometer. Other end of the potentiometer is connected to capacitor, and the capacitor free end is connected to MT1, and this MT1 connected to the other end of the power supply. The capacitor voltage, which is connected as a gate voltage across gate and MT1 of the triac. So that capacitor voltage is connected through diac, in order to have a better control over firing angle. Okay, and here actually, so this lamp is a load, triac is the device which controls the voltage or the power flow to the load. So this basically forms the main circuit, that is a supply, load, lamp load, and triac forms the main circuit. So these resistors along with the resistor and a pot, then the capacitor and diac actually forms the RC firing circuit which is required to generate triggering pulse for the triac. So same triac we can see here. So this capacitor point, so voltage across the capacitor, this is our reference point. So voltage across the capacitor is connected through diac. You can see over here it is connected through diac to the gate terminal of the triac. So that will give the gate pulse to the triac at appropriate instant to trigger the triac. So this forms the complete AC voltage controller circuit. So we need to observe input voltage waveform across the load, voltage waveform across the triac, and also the voltage waveform across capacitor, and we also need to observe the effect of changing firing angle on these waveforms. And we need to use digital multimeter to measure the RMS value of the load voltage for different firing angle, and we need to plot the load voltage against firing angle. So let us make the connections to observe input voltage waveform and load voltage waveform. So already cords are available, it is already connected to the circuit and it is available for observing the load voltage. That's waveform across the load. So I'll connect positive to the positive of the CRO, negative to the negative of the CRO channel. We need to measure the load voltage using load RMS value using a digital multimeter. So set the digital multimeter to measure the AC voltage, the AC RMS voltage. So connect the positive terminal and also connect the common terminal to the reference terminal of the circuit. Okay. And also we'll be observing the input voltage waveform along with this. So let me connect positive terminal to positive terminal to this point, positive of the CRO channel to this point, that is over here. Okay, so we are observing the input, that is nothing but we are connecting between these two wires. So this is our reference, so I need to connect it over here. Okay, so connections are done. So now let us switch on. So as you can see, bulb is glowing. So keep the power scope in 100x attenuation mode. 100x attenuation mode. So now you can observe the waveform. This is the load voltage. This is the input sinusoidal waveform which you can see. So now if I change the firing angles, so you can observe the load voltage. Now it is 35 volts RMS across the load. Now also lamp brightness you can see. So less brightness you can see on the lamp. Now if I change the firing angle, so if I reduce the firing angle by changing the position of the potentiometer, so you can see brightness of the lamp is increasing or firing angle is reducing, which you can observe on the waveform. Firing angle is reducing, so which means that more power is delivered to the load. That is why brightness of the lamp has increased. And also the load voltage, earlier it was showing 35 volts. Now for this particular setting, so output RMS voltage is 132 volts. So vary the firing angle and note down the value of alpha and also the corresponding load voltage, and tabulate the values and plot alpha versus VL. Also observe voltage waveform across triarc and also capacitor. So now I am disconnecting the input voltage waveform. Now I have connected across triarc, and you can observe the waveform across the triarc and load voltage simultaneously. Okay, so the load voltage and this waveform is across triarc. Okay. So we also need to observe the waveform across the capacitor. Now I have made the connections. So I have connected the CRO across capacitor. You can observe the waveform on CRO. So we have load voltage and also the capacitor voltage waveform. You can see whenever capacitor reaches a peak value, as a triarc gets triggered. And so you need to note down the waveform, measure all the voltages as well as time axis information, and plot the waveform for a particular alpha. So if I change the firing angle, you you can look at the changes in the capacitor waveform. So you can see that voltage peak is moving as I change the firing angle. The position of the voltage peak which triggers the triac is moving. It can be observed.